Hello everybody, how are you doing? Today we are going to be discussing characteristics of waves. Characteristics of waves. By the end of this lesson, you should be able to identify the crest, draw, amplitude, wavelength of a wave. You should be able to identify and apply the formulas of period, frequency, and speed of wave. Let us look at the representation of waves. How a wave can be represented. The wave, like I told you before, carries energy and transmits this energy from one point to another point. The wave moves in a sinusoidal manner. As you can see, this is how a wave moves. Moving like a sine, as we have in a sine graph. That's why I said it moves in a sinusoidal manner. So this is how a wave carries energy from one point to another. The wave we are talking about here is the transverse wave. The type of wave whose movement is perpendicular to the movement of its source. Okay, now this particular wave now we are talking about has some characteristics. Every of these waves, the sound wave, the light wave, mentioned them, they have these characteristics. Every of these waves has amplitude, wavelength, period, frequency, speed or velocity. So we are going to be looking at them one by one. But let's consider the wave. This particular wave. This is the wave represented in green color. A wave has what we call a crest, the crests, and a trough. This is the crest of a wave. Just take note of these positions. If this is a wave, this particular position of the wave is called the crest, and the bottom part is called the trough. Take note of wavelength. From one crest to another crest makes a wavelength. Take note of amplitude. From this white line, which is the equilibrium position or the rest position, to the top represents an amplitude. From this line to the crest, or from this line to the trough, the point of trough or the point of crest, is called the amplitude. Okay, so we're going to be looking at these characteristics one by one. Let us start with the crest. Crest, like I told you, the crest of a wave is the high point of the wave. The highest point of the wave, just like I've shown you. While the trough is the low point of the wave. The low point of the wave is the trough. Okay. The amplitude is the maximum displacement of that wave from the rest or equilibrium point. The amplitude, like I told you, from the rest point, this is the rest point I'm talking about, sorry. From this rest point, the maximum displacement, the maximum distance of this wave from this point, that is from this particular position to this position, is the amplitude. From this position to this position is the amplitude. The maximum displacement of the wave from the rest or equilibrium point, that is the amplitude. The wavelength. The wavelength of a wave, wavelength wavelength is denoted by this symbol, lambda. This is the symbol for the wavelength of a wave. The wavelength of a wave is the shortest distance between 2 points that are in phase. The shortest distance between 2 points that are in phase. I'm talking about the distance made by this wave when it covers a cycle. A wave will make a cycle when it repeats itself again, when its former position is repeated. Later, for example, from a crest, if the wave will form another crest, from the initial crest to the final one formed makes a cycle. 2 points that are the same are said to be in phase, and this makes one cycle. So take note. So the distance of a wave when it makes a cycle is called the wavelength. And this wavelength, like I said, is this distance, shortest distance between 2 points that are in phase. Okay, just like we have it here, from this particular position, which is the crest, to another, the closest crest we have. So from this point to this point is a wavelength. Look at what happens here. Here the wave is about to rise. This is the first position of the wave. Another point where this wave is trying, the closest point where the wave is trying to rise is here. So which means that this particular position and this position are in phase. Therefore, it made a cycle, it represents a cycle. And therefore, the distance between this point and this point is wavelength. Same thing with draw. From this point, from a draw to the closest draw makes a cycle. And the distance between two draws is a wavelength. Okay. Period. Period is the shortest time interval during which the motion of the wave repeats itself. Period is the time. It is denoted by this capital T. The unit of period is seconds. A period represents the time taken for a wave to make a cycle. I've explained when the wave repeats itself, it makes a cycle. And the time taken for a wave to make a cycle, to complete one cycle, that time is called period. Time for half cycle is not a period. Time for 2 cycles is not a period. Period is the time taken for the wave to complete just one cycle. 2 cycles means 2 periods. 3 cycles is equivalent to 3 periods. 1.2 cycles is the same thing as 1.2 periods. Half cycle is same thing as half period. But period is the time taken for a cycle, just one cycle. The period is represented by this formula 1 over F, where F here is frequency. We are going to be talking about the frequency. Frequency is the number of complete oscillations or vibrations per unit time. It's like we say frequent, how frequent something is. How many times it will occur for a given period, for a given time. The number of cycles completed for a given time. The number of cycles or number of oscillations of vibration completed per unit time is the frequency. The frequency is the reciprocal of period. Look at what I mean. Remember that period is 1 over frequency. Now, if you make frequency subject of formula, we still have it that frequency is equal to 1 over period. This big T is period. It's not same thing as small t. Small t is just time for a given cycle. But big T is time for one cycle. The unit of frequency is hertz. Hertz. Hertz is the unit of frequency. Velocity. Velocity of the wave, v, or the speed of the wave, it represents the speed of the wave. The velocity, that is the distance covered by this wave per unit time. That is the velocity of the wave. And the speed of the wave depends on the property of the medium through which it is traveling. The density of this medium, how thick the medium is, the property of the medium affects the speed of the wave, the density of the medium. So the speed, as we know, is equal to distance over time. Here, the distance we are talking about for one cycle, distance is what? Wavelength. Distance for one cycle. While time taken for one cycle is period. Therefore, speed is the wavelength over period, which is same thing as frequency times wavelength, or wavelength times frequency. Take note. Speed is frequency times wavelength. Remember that 1 over t is wavelength. Sorry, is frequency. So frequency times 1 over t is frequency. So frequency times wavelength is the speed of the wave. Okay, so in our next class, we are going to be looking at how to apply these formulas, how to use them in solving examples, finding the missing values of frequency or period or speed of the wave or time or the number of cycles, as the case may be. Thank you very much for listening and viewing. God bless you.